Welcome to the PTCI Tech Panel. I am Sean Barbary and this is
Elizabeth Brown.
And today we have with us Randy Yale and Brian Ho. Randy is a broadband, PTCI's broadband network technician.
Yes.
Brian is our broadband network and data services supervisor.
Yeah, it's a mouthful, yeah.
Welcome, gentlemen.
Thank you. Thank you.
So here we are at the end of 2017, and over the last 10 years, we've seen a huge increase in broadband devices in the marketplace. Typically, you were seeing your laptops, your computers, your gaming systems, but now it's tablets, cell phones, refrigerators, televisions, central heat and air units, your front door camera, security systems, IP-controlled telephones. It really seems like everything now is connected to or depends on high-speed internet. Now here at PTCI, we've had an ongoing project to supply the areas we serve with fiber to the home. This fiber allows up to, in some areas, gigabit speed internet, which is amazing to me because there's not a lot of places in the United States that can actually boast that. But as always, there's growing pains, there's adjustments, and Elizabeth and I invited these guys over today to give us some more details.
Okay, Randy, so customers are able to call in when they have these internet-based troubles. We call that instance a trouble ticket. When a customer calls in, they speak to our repair desk, and they have these issues. Sometimes they are not able to connect to the internet, or sometimes their speed seems slow. I've kind of taken a little bit of time to look at some of these trouble tickets, and it seems like sometimes that issue is home-based. Can you explain this?
Yes, as a matter of fact, we just went over trouble tickets this last month in October, and 83% of the internet trouble tickets were actually based on customer devices or customer issues. Some of those issues are usually physical issues with the router. Sometimes the router is 4 to 5 years old and it's never been updated. Just like any device that's electronic, as iOS or any other thing along those lines, a firmware upgrade is needed to fix bugs and crashing issues or just to keep people from being vicious to your device. The other thing is hardware changes. Hardware changes such as going from 2.4 gigahertz to 5 gigahertz wireless is different equipment and it requires more processing power. So there are many things involved with keeping the router up to date as well as getting newer devices, not just a new PC, but maybe you need a new router or something along those lines. Several times we've had people just reboot the router at the house and that fixes the issue. It's usually a temporary fix. So that's number one thing. The next thing they do physically is they usually they can do a firmware upgrade, and that could fix some of the bugs or the issues that they see where it crashes after those few days. Another thing, maybe just, it's a 5-year-old router and it has too many devices now. When they got it, they had one wireless device kit attached to it. Now they got 7, 8, 10, 20, we don't know. So it may depend on that hardware of that device. Another issue may be location of where the router was placed. Sometimes the router is placed inside a garage and it's underneath a bunch of bicycles or something, and over time stuff accumulated over it. So it causes interference or no room to, or there's no way to talk to it without something being in the way. Part of that interference may be an addition to the house, and when they did the addition, it was actually metal, and metal and wireless technology do not mesh well together. Sometimes in older houses, there's a wall that's plaster, and behind the plaster is chicken wire. So there's several things that cause it not to be able to communicate as well or over a certain amount of distance. Other things that could be is, again, with new devices coming in the house, 5 years ago, you maybe had a baby and had a baby monitor, and that's it. Now you have a video baby monitor. So those run over the same channels, same frequencies as the wireless router. It could be a garage door opener. Could be a microwave, could be your home phone, which those are becoming more obsolete, but they're still existent. So some things run over that 2.4 or the 5 gigahertz frequency that causes issues trying to connect to the internet. And it may be not all the time, it may be certain times. And one of the biggest issues we have is, it was never thought of as big at the time, but just as things evolve, the 2.4 is being run over because now it's not just one person on the block that has wireless, it's everyone on the block has wireless. The wireless is kind of synonymous with internet. So everyone has that for their equipment in their house. And I've brought along some slides. Hopefully we can kind of look at them and I'll kind of go over what's going on.
We
if
can.
you guys
We'll,
agree
we'll
with that.
superimpose those over.
Okay, so on these slides, I kind of went over what the Wi-Fi is. There's two different frequencies. There's 2.4 gigahertz and there's 5 gigahertz. Big difference is the lower frequency used on the 2.4 gigahertz. With a lower frequency means it can go longer distances. The problem with the lower frequencies, I mean, it sounds great and all that, but when you only have a certain number of channels to work with, you overrun one another. So as you can see, indoors, an average 2.4 gigahertz router goes 150 feet, and that's going through walls and other objects. And if it's just wide and open, it could go up to 300 feet, if not longer. There's only 11 channels that are non-overlapping. Most of the times there's a 20 megahertz channel width on most routers by default. So it only allows 3 channels available, even though it shows 11 channels in the list of options, but they actually overrun one another. On the 5 gigahertz, it's about a third of the distance that it covers. So it's more in-home and not as much going to your neighbors as much. There's roughly 90 feet outdoors, and then there's 24 non-overlapping channels, which means you could have more customers in a smaller area that are not fighting for the same frequency or the same channel. So on this next slide, it kind of shows those channels, and it's talking about the 2.4 frequency, and as I mentioned, those 3 channels, which are 1, 6, and 11. And below that, it shows the 2.412, 2.437, the different options that they're on. And if you, like I said, the 20 megahertz difference, you can see how they overlap one another with just only 3 channels. You only need those 3. With the 5 gigahertz below that, you can see there's much more options and much more space available. So that's kind of the background on the wireless end. Now we'll go into why it causes problems when you see a block. So on this next block, or next slide, you see the block. That's kind of, it's a block here in Guyman, and it's pretty much my neighborhood, you know, because that's what you go by.
Use what you know.
Use what you know, exactly. And my neighbors are roughly 60 feet, my next door neighbors side to side are roughly 60 feet from me to the center of the house to the center of their house. And then the neighbors behind me through the alley are roughly 120 feet, so almost double that. So they're not too far away. And knowing those numbers about how far your wireless can reach is where it can come into problems. So on this next slide, it shows the red house, which could be my house, showing if I have an indoor ONT or indoor router, the coverage area that it would cover compared to the neighbors on my street. As you can see, it covers almost my entire city block in this instance. It covers quite a few houses, almost a total of 8 houses in this instance. Now, if I were to put that same router outdoors as seen on this next slide, you can see I can cover more than just my block. I can cover several blocks. So whenever you have that much of a coverage area, it's tough when you're limited to 3 channels. So now let's go back to that we'll go back to that slide where it shows my coverage area with my indoor Wi-Fi router. You can see where I am covering my block for the most part. And say I'm on one of the channels as I talked about before, but let's say that we add it spaced out correctly where say it's the best case scenario, which isn't always the case, but we'll go best case scenario where you spread out the houses over different channels. And as you can see on this next slide, all the red houses are on the same channel. And all the different colors represent their Wi-Fi signal. So we can see how much overlap on the exact same channel that we're using is on our house. So when you look at that, almost every single house on this map is overlapping our house, which could cause interference and slow internet speed. And once we zoom in on our house to see how much it is, I mean, you're pretty much, unless you're on one corner of the house, you may not be getting great internet speed. So the issue there is just seeing how different channels and the limitation on channels on older equipment, the 2.4, can cause issues on this current setup.
Well, that was interesting. But Brian, let's dig into some of the actual devices that are being installed in the homes and learn about that.
Sure. I think that as you've mentioned already, something that's become popular is what's called the Internet of Things. IoT is a lot of times the acronym you'll hear used these days. So pretty much any new device that's electronic based is probably going to be capable of tying into the Wi-Fi network that's in your home. Chances are that system probably talks to something out in the cloud for delivering either the ability for you to manage it remotely, get reports and stats on the unit, or get software updates on its own. In some instances, you have things like thermostats made by Nest, I believe, is a really popular thermostat. There's also, like you mentioned, there's refrigerators where you can request a snapshot from inside the fridge to see if you have enough milk.
Yeah, that's crazy.
Any of the things like this are all going to require a broadband connection, and they're all going to require it to be a Wi-Fi signal to get inside the house. So every one of those devices, predominantly in the Internet of Things world, Wi-Fi is a must. And then, of course, every one of them eats up a little bit of bandwidth. You have to take that into consideration when you're choosing the package that you take from your internet service provider.
Sure.
Hopefully that person being PTCI, that
Ideally.
company being a PTCI, right?
Yes.
So more of the devices that exist in the home, in addition to having a really good coverage map on some of the things that Randy covered, you want to have really good coverage. Another thing that you really want to concern yourself with are bottlenecks. And a bottleneck is really just a industry term for having some piece of equipment in your home that can't really keep up with the requirements of what you need. So I looked up a few stats on things. I think Randy might reference some of these numbers later in some of his discussions, but I looked up Netflix, right? They have a page that shows you what you should expect, and Netflix is a streaming technology. I'm sure everybody watching probably knows what Netflix is by now, hopefully.
I would have to assume.
I would assume, but it's a streaming service, and it uses a technology for the video called ABR, which stands for adaptive bitrate, and then of course adaptive bitrate streaming. And that philosophy is really the technology that you may see as a customer and you don't know any better, but whenever you start a YouTube video or a Netflix video, it's oftentimes that the first second or two of that video is going to maybe pixelate or be really, really grainy.
Right.
The quality's not awesome. And then as the algorithms built into the system recognize how much bandwidth is available, the adaptive bitrate technology is going to increase the quality of the video, right? So whether you've seen it or known better or not, that's actually the technology that's at play. And this adaptive bitrate technology will do its best to determine what stream you can receive and how high the quality is based on available bandwidth. And here's some of the numbers specifically for Netflix. Everybody's service might be a little different, but just for Netflix, you have just for a required broadband connection to get it to work at all, you need a half a meg. You're moving up into the 1.5 for really low-end quality, 1.5 megs per second. Low-end quality, 3 meg gets you standard def quality. 5 meg is going to move you into the HD realm. Now here's the big jump, right? So you're looking at like Blu-ray or 4K, UHD, your ultra high def is in the 25 megs per second realm. And it's worth noting the fact that this is per stream.
Right.
Right? This is not, I have Netflix, I need 5 meg. This is, I have Netflix, I need 5 meg per person in the house watching.
Right.
Child 1 watching Stranger Things episode 4, season 2. Other child, not quite as far along in the series, watching Stranger Things, totally different episode. You're in the living room watching whatever you like, a House of Cards.
Right.
And all of those streams are going to add up per stream. You really have to take into consideration the math involved in that to determine what broadband package you have.
Absolutely.
Otherwise, you're going to get the
Spinning wheel of death.
little spinning wheel, little buffer action is going to come at you. So you really have to take that into consideration. Even if you don't get the buffering, you're probably going to get a less than awesome experience with really grainy, non-HD quality video.
A lot of pixelation at least.
Lots of pixelation. You know, you're just going to see the big blocks on the screen. It's going to look really, really grainy, right? So I covered some other technologies worth considering that are pretty popular right now, just to give some examples of numbers. A lot of people will tell you that gaming is really something that's going to suck down a lot of bandwidth. I don't want to make a blanket statement to say that it doesn't do that, but depending on the game, gaming doesn't really eat up a ton of bandwidth, but one thing that it relies on heavily is latency. So you want to make sure that your connection is really healthy. That's one thing. We'll talk about fiber a little bit more later in our discussion, but fiber has really, really good latency, so it should be a good experience for gamers. Again, it depends on if the map is interactive. If you're just simply uploading position on a map that already exists inside the system, it's really per game. Let's see. Another bottleneck that I wanted to cover is the first bottleneck was the accumulation of streams and the math that you need to take into consideration, or you can call us certainly and we'll help you with the math. But
Sure.
a lot of our marketing actually covers how many devices and how many streams you expect to have in the house. But another thing worth considering inside that bottleneck realm of the home is which Wi-Fi flavor you're running. So 802.11 is the generic, right, Randy? 802.11 is the generic Wi-Fi standard. And as that technology's progressed over time, it's come up with different flavors or releases or whatever term you want to call it, and they're usually accompanied by an acronym. Your traditional first round was your B, then you moved into 802.11G, then you went to N, then you went to AC, and now we're at, I don't think there's many products on the market in this realm, but now we're at AX, I believe. You might not hold me to that one. It's brand new, we just talked about it the other day. But in each of those iterations of technology, we moved from the 2 gigahertz spectrum realm, smaller channels like Randy had mentioned earlier, less availability to separate channels and eliminate interference, and of course, the smaller the channel width, the less you can squeeze through the channel. So whenever you start moving into 802.11 technologies that are in the 5 gigahertz realm, you have more spectrum available, AKA bigger channels. Mm-hmm. You also have more complex modulation schemes that allow for higher throughput per transmission, we'll call it.
Okay.
So that's another thing that you really want to take into consideration, and it's a hurdle that we've ran into with our customers, taking higher broadband packages from us, and then of course running a speed test on a laptop from 1998 and wanting to know how come they're not getting their 50 meg package or their 100 meg package or whatever they happen to take, right? So,
and it's not because of the service, or it's just the device, right?
Exactly, yeah, you can touch nothing in the home and come in with a brand new laptop that's not running 802.11G or B or whatever it happens to be running, and you can come in with an 802.11N laptop or an iPhone 8 or 10 versus an iPhone 4, and your speed test is going to improve greatly.
That's interesting.
And that's all has to do with channel width, frequency allocation. There's another technology called MIMO, stands for multi-in, multi-out, but it really, at its highest level, just represents the amount of streams a device can communicate on, stream for lack of a better word. If you really only have one antenna, you're not really MIMO, you're just one by one. So
Right.
If someone was really to do some research into 802.11, they would find on the wiki page, it would say 802.11n can do, you have a number off the top of your head, Randy? I think I may have wrote it into my notes somewhere.
It's on 2.4 or 5 gigahertz as far as how much 802.11n can do.
Yeah, so 802.11n here in my notes, it operates, you can have it on 2.4 or 5 gigahertz, and it can provide anywhere from 54 meg per second up to 600 meg per second, depending on the channel width, which frequency you're utilizing, and of course the interference and signal strength in your house. But it's worth noting that 600 meg a second limitation is a brand new device with multiple antennas capable of doing MIMO. So if you come into the house and you say, hey, I have an 802.11n device, how come I can't get 600 meg a second? Well, these are just guidelines to show you what the technology is capable of if you have the proper hardware in place.
Exactly.
Right.
Exactly.
So Brian, I read now the average home has 20 or more internet connected devices. And as you mentioned, each device uses a certain amount of bandwidth. So when our customers are looking to get a package or a Wi-Fi solution, What kind of speeds and what kind of Wi-Fi solutions do they need to look into?
That's a good question. I think that, as I mentioned before, our marketing documentation does a really good job of giving you some ideas as to what is going to be used in the home and what speed we recommend based on those devices. But the more devices you have that are going to be responsible for streaming video, those are really high bandwidth intensive solutions. So if you have 4 or 5 smart TVs, you know, of those 20 devices on average, if the majority of those are tablets, smart TVs, or media related devices, you're going to need a pretty healthy package. Again, you know, standard math, let's go 5 mega stream. If for HD quality, everybody's going to stream all at once, you're going to need probably at least the 50 meg package to ensure that you're getting a quality connection and the video that you expect out of the service.
Some devices require upload speeds to be nice too. So can you touch on what makes that an important factor as well?
Sure. I mean, just a really prime example of upload speeds would be your iPhones. Pretty much every mobile device is set up to pump that information northbound into a cloud storage. So at the end of the day, once you get home, depending on how you have your phone set up, it's probably going to try to talk to the iCloud or, you know, the Google Play Store, whichever type of device you like to carry, and it's going to push all those photos you took today towards the cloud. And as you mentioned, that push of traffic from your phone towards the internet utilizes upstream speed. So while it's not as prominent and not as high on the list for people in determining their package, it's something you should take into consideration for sure, especially if you're, you know, let's say you're into photography and you really want to take a ton of high quality pictures and push them around. A lot of times, another instance would be businesses that are interested in doing nightly backups, or are a branch office that need to push a ton of really big files, pictures, etc., towards a headquarters location. That's when upload speed really comes into play and can be important.
And the home security cameras are becoming so much more popular.
Yeah.
Do those
And
utilize?
that's a good example. That's a perfect example of it. I didn't cover that one because your Ring device. What's a couple other ones, Randy? Ring,
Nest.
This one, yeah.
Any one of those that
Yeah.
you're gonna from your smartphone, most likely is the instance. From your smartphone, you're gonna get some notification and you're gonna want to watch live video. That live video is getting from your house to your phone via that upload connection. So that's a really good point. This is important for the quality that you expect of video, right? You don't want a security video that you really can't get anything out of. So
It doesn't really do much good,
yeah,
does
'cause
it?
it doesn't do much good.
The grainy face is hard to detect.
Exactly.
It might be a person, I'm not sure.
Yeah.
Okay, Randy, so we all remember dial-up connection, right? And the lovely
Yes.
sounds it made. And
Yes.
I'm sure we could all mimic them now, but we really don't want to because that would just be, it would be odd. But can you explain to us the difference in technology from the copper, which was used to connect via dial-up, correct?
Right.
And now we have this fiber that we've been building a network of. So can you tell us what technology has done in those kinds of transitions?
Yeah, I'll do the best I can. Well, you know, copper was first made for our plain old telephone system, for our POTS line. So at first it was just the 2 pair coming into the house, for one to provide power to ring and the other one for the electrical impulses to talk to the other person on the other end of the line. As technology progressed, they started figuring out ways to put a splitter in so that way you could get internet connection, kind of get that where it's a two-way street. Problem with that is that you're using old technology on a newer technology that was limitless at the time. So copper was good for the time, but as everything else goes, just like your phone changes, sometimes your back end needs to change as well. Because copper has been great, and it's great for shorter distances now, but as broadband keeps increasing, speeds keep increasing, it's matched for what we can serve. You know, the problem with copper is, one, it's getting more expensive than fiber. I mean, you hear people stealing copper all the time from different places, off electrical poles, off of telephone poles, just to turn it in for money. Fiber is getting cheaper. The big difference, though, is, as I mentioned, copper uses electrical pulses to send data across. And when you have multiple pairs and multiple things in the same bundle, it can cause noise and crosstalk. Similar like we talked about with Wi-Fi, the same thing could happen with the copper going across. And it also fluctuates based on weather. If it's a hot day, then all of a sudden it's cold, you may not be able to get the higher speed because the copper expands, the copper condenses based on weather. So it changes based on temperature as well. With fiber, it's glass in the middle. So instead of electrical impulses, it has light that shines through, and it can go the higher frequencies, which means the higher bandwidth. The big thing with it too is being able to do the higher frequencies. It can go 100 times further than the copper plant could go. So the big difference is faster speed, longer distances.
Very good.
So Brian, PTCI has been a company that's always looking towards the future. The technology of fiber came to be, I don't know how long ago. Can you tell us about how that has started transitioning from copper?
Sure. The PTCI, I mean, it's an inside joke a little bit that we would probably use the industry term cutting edge technology, but some people might call it bleeding edge technology. We usually stay right on the very front lines when it comes out to pushing new technology. Fiber itself, we've been utilizing, and this was before my time at PTCI, but somewhere in the 70s or 80s, we started to utilize fiber itself for getting from town to town.
Oh, really?
So we've been using fiber for quite a while. It's just that it was not cost effective till some, as with anything, requests from the market demand, and changes in technology allowed it to be a cost-effective solution in pushing to the customer's home instead of copper. But we've been using fiber for quite a while to get from town to town and provide redundant self-healing ring services to all of our exchanges for quite a while now. I cross-referenced a couple of numbers and found that it was somewhere around the 2006 to 2007 timeframe that we started to deploy copper. Refresh that. In the 2006 to 2007 timeframe when we started to switch from copper to fiber in deploying services to customers' homes. The technology itself, just mixed with the availability of cost-effective solutions, is really what allowed us to get into that realm. And the impressive part that a lot of people don't realize living here is, and maybe because we just don't quite have the same global effect from a marketing standpoint that Google does, is that this was about 5 years before Google Fiber ever became available. So whether people are aware or not, Panhandle Telephone was bringing the Oklahoma Panhandle into new technology 5 years before Google even considered doing it themselves, and I believe it was Kansas City first.
Right.
And since, if you stay up with some of your tech news, Google Fiber's kind of gotten out of that business. They're not really heavily invested in it anymore. I think they're kind of on a holding pattern, and yet in the middle of the Oklahoma Panhandle, Panhandle Telephone still continues to push very hard to try and catch as many customers as possible with fiber to the house. So Randy kind of hit on some of the differences just in the transition from copper to fiber, but there's many benefits there. It's a long-term investment for PTCI, for us providing more and more bandwidth to the customer. Once you really get that piece of glass in the ground between our offices and the customer's house, it takes less and less overhead, maintenance, repair, and cost to deliver more and more bandwidth to the same customer, because you're just looking at changing pieces on the end at the customer's house and maybe pieces at the CO to move to new technology that still utilizes light and that fiber connection to get the speed.
Yeah, the actual fiber itself will do everything we need it to do for a long time.
For a long time, yeah, for a really long time. So it's a really good investment for us, and hopefully investment for our cooperative members as well, to have the availability to get new and improved speeds and services as they're dreamt up by all the people in the world coming up with new technology. So it's a really good investment for us. And some of the areas that we've covered, we have maps and things that give you some pretty good idea where this is, but In that time frame that I mentioned before, in '06 and '07, we were hitting mostly rural projects. I think we started kind of north of Guyman in some areas north of Goodwell around a place called Red Point. And since then, we've really started to focus on some of our, we call them our metropolitan areas. They're they're the bigger towns for the Oklahoma Panhandle, right? So
Right.
Beaver, Forgan has already completed construction and installation. I think that we're 99 to 100% completed with converting customers in those locations. Guyman is 2/3 done with conversions, and a third, the last third is done with construction. So here this next year we'll be doing scheduling conversions for those customers, and then we'll plan to hit a town next year, and I'll let Sean elaborate on when that is. So
Okay.
we don't want to let
Sean Hansen, not
Sean
this
Hansen, yeah, not this Sean. We don't want to let any cats out of the bag, but there's another town planned for 2018, and as long as we can continue to make it happen that way, we'll continue to do town after town and hopefully cover the whole Panhandle with fiber by the time it's all said and done.
That's great. And I think our customers, they certainly like it because it's easier access to faster speeds.
Yeah, it is.
Allows them to compete with the global marketplace too, because these businesses that live out here, they have the demand for broadband that everyone else does, and for them to be able to stay in the game, they rely heavily on those services.
Yeah, there's a huge economic advantage to having available broadband services in an area, and it can bring in businesses. I mean, there is no business in today's world that I'm familiar with, for the most part, that doesn't utilize a broadband connection in some way, shape, or form. Whether it may just be your accounting records to pushing an MRI image to a radiologist,
Radiologist.
a radiologist in
Doctor,
Amarillo,
doctor.
in
Yes.
Amarillo, doctor. Whether you're just uploading accounting files or you're doing something in the telemedicine industry, it's having a high-speed broadband connection that PTCI can provide is a great way to improve the business prospects for that community. So
Absolutely. Absolutely.
that's one thing we really focus on is we really are dedicated to providing a great experience for a lot of the CEO Sean would say anchor institutes, right? So we're really dedicated on getting service to schools,
OPSU.
universities, any education, your hospital, your libraries, your anchor institutes, right? And then of course the benefit of hitting those is that while we're doing construction for those projects, we also pick up all of the residents along the way, so everyone has access to that new system.
Randy, we kind of talked just now about businesses and how they utilize fiber. But can you tell me what a household might expect over their internet connection via fiber?
Yes, as we've kind of previously talked about, a lot of devices now do video over the internet now. So before, whenever I had 4 TVs that were non-smart TVs, now all of a sudden I have 3 smart TVs and a Roku stick attached to the 4. So all 4 use the internet. The big difference is kind of like what Brian said, is with a TV you want the HD or the Ultra HD, and you want 5 megabytes for each one. And with 4 TVs, that's 20 meg minimum for HD, but I got a 65-inch TV that I want to see in Ultra HD because I paid for that, right? So it can add up quickly as far as the amount of bandwidth you need just for that. I know just in my household, I can have my kids playing online gaming, plus watching YouTube on their device at one point, my wife be in the room watching a Netflix series, I be in the next room watching Thunder highlights or something else over the internet, over the top, and it can add up to a high amount of bandwidth. And with fiber, it gives us the ability to provide that bandwidth to the customer.
I have an interjection on that. I was just thinking of a scenario where, Christmas is right around the corner. Let's say you had previously just one TV. It was a smart TV. Let's say it's a 32-inch TV, and you're used to your HD experience on a screen that, TVs continue to get bigger and bigger, but it's HD, you're used to it, you like it, but you go to Best Buy or whatever store you shop for your TV at, and they're going to talk you into something ultra high def, something 4K related, and they'll ask you, a handful of questions. To some extent, they'll help you out. They'll definitely help you out in relation to you needing a new TV.
Especially a bigger one.
Especially
Yes.
a bigger one. So you're going to leave the store with something that you want to have 4K capacity, all these bells and whistles. Let's say it's 65 or 70 or whatever, you end up leaving with this huge TV, and you're going to go home and you happen to have the 12 meg package at your house. And you're going to come home and you're going to plug that new TV in, and you're going to watch the same content from Netflix or wherever that you were watching before, and you're really not going to see a difference between this 32-inch TV that you had and this brand new Christmas present that you're super pumped about plugging in Christmas
Right.
morning or whenever you bring it home, right? So, keeping in mind that adaptive bitrate technology that we discussed earlier, you're going to hit that limit on your 12 meg package and really making your new TV sparkle and shine like you expect it to, with the great colors and all the high definition advancements of ultra high def. You're not going to see unless your broadband connection is capable of delivering that to your house. So it's really about, and PTCI is here to help answer those questions, right?
Sure.
I know that a lot of times buying a TV can be confusing, so or any technology that's really connected to the internet. We're here to answer those questions and help you choose which package best suits your needs. But that scenario is a prime example of what Randy's talking about. Sometimes you are missing just one piece of the puzzle, and you're going to end up thinking this new TV is horrible, and you
Not so
wasted
good.
your money, and it's really not. You're right, it's really not the TV. It's just
And
that
you've
you
messed
need
with all of the settings for 25 minutes
exactly.
already anyway.
Yeah.
Okay, Brian, so a family has a 100 meg package at home.
Okay.
And they want to be able to experience internet all over their house, but they don't have jacks everywhere. What are specific options that we have for them?
Yeah, so the popular technology, and it may not even result in jacks or otherwise, is that most devices you buy nowadays connect with Wi-Fi. It's pretty regular that you go out and get a new laptop, and unless you specifically ask for an Ethernet NIC in it, it might be Wi-Fi only. That's definitely the case on tablets, and it's obviously the case on phones. So
Sure.
pretty much most device, your IoT things, they all connect with Wi-Fi. So to have a good experience with your broadband, you're definitely going to need a Wi-Fi router in the house. And that can be a benefit where our service of My Wi-Fi can come into play. And I think before we get too far into My Wi-Fi, it's good to cover the concept that internet service is very heavily persuaded by perception. You have this whole equation of things that are at play that are involved in providing your internet experience. So if any one of those pieces breaks, your perception in relation to your internet experience, it goes out the window.
Suffers.
Whether it's one little piece or the whole thing, it doesn't really matter. All you know is that whenever you clicked a button, you didn't get where you wanted to go, or the video didn't play, or it buffered, or whatever the problem is. So we really focus on trying to improve the customer's perception on products. Hopefully making the entire equation something that is good hardware. It gets managed by someone that has some experience in the IT world or with telecommunications, and then of course it gets upgraded and kept up to speed and up to date with new firmware so that bugs and security patches and flaws in the software that those units run on are up to date and hopefully not causing problems for the customer. So one thing nowadays, I'm bringing the conversation back into your question, is that...
Yeah, I knew you'd get there.
I get there. The perception of this entire product of the internet or broadband is heavily controlled these days with Wi-Fi. So what we really like to push to our customers is that they take a service we provide called My Wi-Fi, and we actually provide the hardware itself, and it comes for a monthly fee. I believe it's $9.99. And it's a really good service to have out there so that, if you have problems with your devices, you can come to us with questions. We can hopefully resolve the issue, and at the same time we have access to your router to really troubleshoot properly what's going on. Randy alluded to this earlier about us looking up tickets, and we have roughly 12,000 data subs. Less than 3% of them, 430 some odd troubles we took in the month of October, and 83% of those 430 are resolved by customer equipment So that is things in the home. That means that we found something wrong with the laptop, the setting was wrong. The Wi-Fi, if it happens to have a dongle, or the integrated card for the Wi-Fi is turned off. Coverage was bad on the $30 router that they picked up on Craigslist or something, right? Any one of these settings in it, and this by no means is it our idea that we want to point the finger at those people that have problems with their own devices, because we want to control the perception of the entire service.
Sure.
So that's why having our My Wi-Fi's really helps the customer, and it helps us provide a better service for the customer by controlling that whole perception.
Well, if I have my Wi-Fi and I'm having a trouble, I can call you and you can look at it from your end and then diagnose without having to have all of the questions. Is your router plugged in? Have you done this? Have you done that? It's so much of a simpler process. Is that correct?
That is correct. The hardware that we use, I mean, it's a tech talk, so it's called a Gigacenter, and it's by a vendor that we really invest in and deploy heavily with. And this product was built to improve the experience for the customers. It has many tools built in that are going to be able to give you stats on each device. We'd be able to log in and take note of the laptop that you're referring to that you're having issues with has a really, really low signal and a really low quality of Wi-Fi. We'd probably cross-reference which room of the house you're in, and we'd also try to either improve the location of the existing router that we provide, or provide an additional piece of hardware that extends the signal further into houses that are a little bit bigger, or maybe have
Interferences.
walls that create interference, like Randy mentioned earlier. We have a lot of construction around here where there's plaster walls, and they use that material that looks a lot like chicken wire to run the plaster into, and that creates basically a barrier for the Wi-Fi signal and really causes havoc on customer services. So those tools, all that feedback that we can get, helps us resolve the customer's problem quicker. It also hopefully gives us the right statistics to help them improve which package they should choose.
Right.
It just gives us a whole load of information that helps us make the customer's perspective on their internet service better.
These Gigacenters are really top of the line too, and correct me if I'm wrong, but aren't they the self-organizing network?
Yeah.
So when we're talking about the 2.4 and the 5 gigahertz, I don't have to go, which one does my TV need to hook up to? Which one does my laptop need to hook up to? It sees which is the best path for them, correct?
You want to hit on that, Randy? Randy works with the Gigacenters.
The big thing with the Gigacenter is, as Brian has mentioned, is there's a lot of self-healing, as well as when we log in, we can actually see stats that we can't see with a normal home router. One of the biggest stats, along with is for each individual device, is the site survey. Kind of like how I mentioned with channel interference and everything else. It'll tell you if there's interference on a channel and say, hey, I need to change channels. And you push a button and it changes channels. Then you can be like, hey, how are you doing now? And it's as easy as almost looking like at a stoplight, because there's green, yellow, and red. So you look and see which instance you're in and and change that setting, and should fix most of the issues.
So these frustrations that we've all been experiencing, they're kind of unnecessary, correct?
Correct, yes.
They can be. We can improve them. They're really, the hardware in them is very robust and very powerful. There's multiple radios. I believe the latest version that we have is a 3x3 MIMO. It may be even a 4x4. The new one's coming out next year, actually going all the way up to 12x12.
Wow.
Some really, really cool and advanced technology to provide throughput on Wi-Fi that is unheard of, right? We don't have it yet, but it'll be cool once we get it. And like you said, the difference between BG and N, all that stuff, because of those dual band radios, there's enough hardware in those devices that we can transmit both at the 2.4 range and the 5 gigahertz range, so that regardless of how old your device is in your house, you'll still have some sort of Wi-Fi access. Now, does that fix your 1998 laptop from only getting the 10 meg test because it's still running on the old technology? No.
I'm surprised your 1998 laptop still works, by the way.
Exactly, yeah.
It's on its last
only,
leg.
only Randy, he's really good at keeping it running, so
Nursing along.
that's right. So you're not only going to be able to have all your devices on the system and functioning as you expect, you're also going to be able to cross that bottleneck that I referenced earlier in relation to speed. And that's something that we really have to focus on internally and make sure PTCI's procedures follow that. And this device allows that, because whenever someone does take, in this instance, the 100 meg package,
You want 100 meg.
yeah, we've had people that will take a 100 meg package from us. They've got their own Linksys from Walmart, seems to be a popular brand, but fill in the blank, Netgear, Linksys, or whatever. And it's a BG80211 router. They upgrade from the 12 meg package to the 100 meg package. They hop on their laptop or their new cell phone or something from a device perspective that's capable of getting those faster speeds, and they run a speed test and call us immediately and want to know how come they only got 38 meg speed test on their 100 meg package. Well, again, it's not a finger pointing exercise by PTCI, but we can go out with our own equipment and our own router, and we can show the customer that their connection is healthy and there's absolutely nothing wrong with their internet connection. But
It's almost like they're not speaking the same language
Exactly.
or something of that nature.
But from a perspective standpoint,
Right.
you can see how the
Oh, well,
customer
sure.
in that scenario is going to be upset, and they're going to say, perception,
Mm-hmm.
this whole equation of the internet is broken. I'm not getting what I pay for. So
So-
that's where the newer router comes into play. the
And for
Giga Center.
$9.95 a month,
Yeah.
for me to be able to not have all of those crazy problems, or if I do have a little bit of a problem, I can call in and you guys with the brains can sit there and push some buttons and get it running smoothly.
Sure.
I'm a happy camper.
Yeah, I mean, I think we've got several customers that take that service, and they seem to enjoy it. It's seamless, it's easy. We hopefully provide a service that the customer enjoys. Most of our customer surveys reflect that everyone really enjoys that service. A new service that we're coming out with, we haven't really highlighted all the details of it from a cost or deployment perspective, but it alludes to and tries to match this new philosophy that Google and Netgear are coming. Have you guys seen
The
Google
mesh.
Wi-Fi, the mesh? So we're testing with units right now that provide a mesh scenario off of the Giga Center. So in larger homes or homes with interference problems from walls or homes that have large square footage and coverage area issues, we'll be able to go in and place additional devices to provide a mesh experience in the house. So, and that's really something that we're looking forward to compete a little bit with the off-the-shelf solutions that you can get.
Provide
from,
a better experience.
It's a better experience, exactly. Like we mentioned throughout this talk, your major issues are going to be interference and or coverage,
Right.
right? So once you line out the interference issues, then you got to make sure that it's in that back 3/4 bathroom. You're going to be able to stream your YouTube or whatever.
Where everybody spends a lot of time.
Yeah, exactly. Yeah. So that's kind of something that customers can look for moving forward. I don't know. I don't have any release dates or anything like that, but it's something that we're working on in our lab, and it hopefully shows promise and some availability for the customer to get better coverage in the home, because I don't think Wi-Fi attached devices are going away, right?
I can't imagine that they would.
Yeah.
And there's just more and more every day.
Exactly. So we're doing our best to provide a product that already creates a good Wi-Fi experience for customers. It's managed by people that know what they're doing, and then on top of that, we're keeping up with industry standards on products and developments in that realm that change how the technology works. So we're keeping pace and hopefully providing a great product for all of our customers.
That's awesome.
Yeah.
Well, I don't know if you guys had anything you wanted to add additional to that, but we've really enjoyed having you guys here. I want to thank you for coming in and sharing your expertise and your knowledge with, I know I learned some stuff today.
I learned a lot. Yes.
And we'll probably have you guys back again
Yeah, that'd be great.
at some point. So
All right.
once again, for Elizabeth,
Yeah. Thank you guys very much.
Yeah,
Thank you.
thank
See
you
you guys
guys.
later.